In this video, we are going to do a demonstration on Design X Essentials. Now, Design X Essentials is a new product for 2022, and what it is a subset of Design X. And if you know what Design X is, it is the most powerful reverse engineering tool on the market today. So what we're going to do is we're going to go through a basic demo on that product so you understand how it works. Now, if you already know how Design X works, this may be a little bit of a refresh, but during that demo, we will highlight some of the differences between Design X Essentials and the full-blown Design X. Now, we have a separate video, and there'll be a link in the description below, a video showing all the differences between Design X and Design X Essentials. So if you already know Design X or pretty familiar with it, that may be a better video to watch. Now, if you are interested in Design X Essentials, we can provide you with a 14-day free trial so you can check it out yourself. And if you end up purchasing from EMS, one of the things you get from us is exclusive EMS training that you're not going to get anywhere else. So what we're going to go through is a basic part and showing you the workflow with Design X Essentials and pointing out some of the differences with Design X. Okay, so to get started, let's go ahead and import some scan data, and you can just come here. This is your hit cancel for a sec. So if I pick the little arrow, you can see this is just your file. You can open, new, etc. Default is to open, so we'll click that. Now, typically 3D scan data is going to be in STL format. Could be OBJ, but most scanners nowadays will import STL or export STL, and that's what we're going to import in. Now, one of the issues with STL data or polygon data, mesh, whatever you want to call it, is there's no header or flag or information in the file. It's a pretty dumb file, and there's no setting in there for units. So depending on what you've preset Design X Essentials to, it's going to come in, and you can see it's saying, well, this is set to millimeters on the import, but gee, that would make the file about 0.38 inches in size. Now that could be, but it's kind of a nice feature. If I set this to inches, which is what it was scanned in, you can see it says, oh, okay, the extents of the part now are 9.75, and I say okay because that's about right. So this is a machine part, okay, and this is the raw scan data here. Now, what is scan data? Let's turn the planes off for a minute. Well, scan data, as we mentioned, is a mesh. What is a mesh? It's really just a bunch of triangles, okay? It's a polygon mesh, okay? So, from a distance, let's turn off back to the normal. You'd look at this and say, hey, that looks great. It looks like a CAD model to me. But you start looking close, you can see it's a little rough in there. There's actually areas down some of these holes, the holes where we just don't even have scan data. You can kind of see like there. We're missing some scan data there, etc. It's just polygons, okay? I mean, it's pretty clean. This was done with a Creaform HandyScan scanner, so, very high quality, but it's not CAD. There's no intelligence to it. You really can't use it for machining or mold making or anything. I mean, you could close it all up and 3D print it, but you can't change anything, okay? We want to take this and turn it into a CAD model that has real planes, real cylinders, real features that can then be used for all types of downstream manufacturing, assemble it with some other parts, just all analysis, all kinds of things you could do. Okay. So we're going to walk you through that process, but typically when it comes in, it's going to look something like this. Scan data is just polygons. Okay. And it's an exact replica of the manufactured part, which may be good or bad. You'll see when we get into this. Okay. So first thing also you might notice is it's not in a coordinate system. If I go to the true top, side, front view, you can see because we didn't define a coordinate system when we scan. Now you can do that, or you can put it in one when you're done scanning, depending on the scanner and the scanning software, but we didn't do it. So we'll do it here. So that's going to be the first thing. We want to get this thing so that we've got some, nice views. Now, typically when I go to put something in a coordinate system, I'm going to look at, what's kind of the major features? What do I want to align it to? So obviously this base here would be a good place to align, and then maybe this sidewall here, okay? So to do that, I need to establish some information to put it in a coordinate system, primarily really of a couple of planes. To do that, I'm going to go to the region group. Now, what is a region group? A region group really just color code scan data. I'll explain more as we go. Now, if you're familiar with Design X, we do not have the auto segment here, and we have some limited region group tools, but we have everything we need. So what I want to do is I want to, this to me looks like a plane, right? This bottom here, that's pretty flat. That's got to be a plane. This has to be a plane. These have to be cylinders. This is certainly a plane. This is a fillet or a cylinder, etc., right? So what I'm going to do is I'm going to select the data, and we have different tools. So for example, there's a paint tool where you can kind of paint around like this. There's the lasso tool where I can, wrong tool. Sorry, there we go. The lasso tool where you can basically select different triangles. But the tool I like to use, square box, okay? And that's just going to select anything that crosses that box, the triangles, okay? Tool I like to use here is this one called Smart Selection. You basically click and hold your left button, and as you move up and down, you can see it's going to look for similar shaped geometry, and the more I move up or down, the more it expands or contracts, okay? So you can see what it's done. It's grabbed all the, because I want to sample all of that data, okay? And I'm going to say insert region group, okay? And all it's really doing is color coding the data. And now when I highlight over, you see it says green. It says, hey, that's a plane. So it's basically just color coding the geometry. There's nothing really there yet. It's just saying, hey, it looks like a plane fits through here. So it's going to color code it, okay? And you can do this with, like I said, cylinders and everything else. Okay, so we'll do the same over here. I'll just expand out and I'll hit insert, okay? So that's really all I need. Now I can create additional ones. I'll get more into that, but that's all I need for setting up my coordinate system on a part like this. So now we step over to the alignment tab. We're going to do an interactive alignment. Hit next. There's 3, 2, 1 and XYZ are kind of the main ones here. I usually use 3, 2, 1. And I'm going to pick my main plane. That's going to be my X and Y. Okay. So you can see what it's done. It's locked that coordinate system onto the X and Y. So if you look at X and Y now, they're right on that region group. Okay. And then for my vector, I'm going to pick this plane. And what it's going to do is use the normal vector of that plane. And now you can see the Y is perpendicular or normal to this plane here. And of course, my Z is going up. So that's exactly what I want. Now you can flip these around, up and down, but that's exactly what I want. Now I could take it further and actually, this is the origin. This will become 0, 0. And I'm just going to say, look, I don't really care where 0, 0 is. Sometimes you do, sometimes you don't. But for this, I'm going to actually just leave it there. Okay. And I'm going to hit OK. So now when I go to my views, you can now see what's happened. So now we've oriented, or aligned it. We locked it down to this bottom plane first, and then we use the vector on this plane here to get this locked into a coordinate system, okay? So you always want to get it in a coordinate system, unless it's something so organic. But as long as you have planes, cylinders, things like that, you can definitely create a coordinate system, okay? So we have created the coordinate system. I'm going to turn those region groups off for right now, just so I don't have to look at them. And again, it's just color coding the scan data, okay? Now, when we get ready to start doing CAD modeling from scan data, you really want to look at your part and take a little bit of time to determine how you're going to model it, right? What makes the most sense? And I always try to look at what's the most important or the major feature I want to start with. And in this case, it's going to be this bottom. This main profile shape is definitely, everything mounts to this. This is some kind of bracket. And obviously there's, it's bolted down. So we really want to start with that and build up. Okay. Now let's turn back on our reference plane. So because we created that coordinate system, our top, front, and right planes are now in that coordinate system. Okay. So here's our front, here's our top, there's our right. So they're right at that origin point. Okay. So for our first sketch, we're definitely going to want to start with the front plane. and right down at the bottom of the part. That's the bottom. That's where we want to start with our sketch, okay? Because we're going to do solid modeling, which is sketch driven, okay? So we go to our sketch tab, and under the sketch tab is mesh sketch. So we're going to pick that. We're going to pick our front plane, which is the bottom of our part. Now, what you'll notice is when it cuts this reference sketch through the scan data or this mesh sketch, you can see what it looks like right on the bottom of the part, which basically the part is not completely flat. The edges are all kind of rounded off. So what we want to do is we want to take this little arrow and we want to actually sample up higher into the scan data. Okay, so I'm going to move up. You can type in a value if you want, but you always want to get off that bottom. You want to get away from the radius edge. You have to be careful if your walls have draft. You don't want to go up too far, but you want to get up off of that edge. And then you hit OK, and it's going to create a reference sketch, but it will be at that front plane, at that bottom, okay, even though we sampled up higher. So let's hide the mesh. And what is a mesh sketch or a reference sketch? Well, it looks like geometry, but it's not, okay? It's just visual, okay? Our next step is to actually build a real sketch. And if you've ever done any CAD modeling, you probably know how to create sketches. So we need to go ahead and use this as reference to build real sketch geometry, which is lines and arcs and splines, etc. So let's get started. So the first thing I'm going to do is these are all my sketching tools. Now, one thing that's not here that's in Design X is what's called Auto Sketch, where you can window in on an area or the whole part, and it'll attempt to create all the entities for you and add all the constraints. And on simple geometry, it works fairly well. On complicated geometry or bad scan data, it doesn't work that well. You end up having to go back and fix a lot of things. So, it's personal preference whether you use it, but in Design X Essentials, you do not have it. So what I'm going to do is I'm going to say rectangle, and the first thing I'm going to do is build a rectangle. And when you move this sketch, you'll see it'll snap right to this reference geometry, okay? So we've put it there, and then we can adjust this side over here right there, okay? Because what I want to do is I want to get the constraints. So this is real geometry. These are lines, and they have constraints, in this case, horizontal and vertical, okay? But I'm going to use this now to build some other lines. And as I move along, it's automatically going to lock in on the center point of that line. And then I'm going to drop down. And then when I'm vertical, you see that vertical constraint come on. So I'm going to draw that. And I'm going to do the same in this direction. And then I'm going to select both of these lines and make them construction geometry. And then I'm actually going to delete these others because I just wanted those so I could find the middle. So why am I doing this? So when you're designing, okay, when you're scanning a manufactured part and then wanting to go back to the design intent, most of the time a part like this, everything's going to be symmetrical. I mean, it looks like it should be symmetrical. So we're setting up the center of the part so we can build geometry and mirror it over, okay, so that everything is symmetrical. So let's actually start building some other geometry. So I'm going to start over here, and I'm going to pick the circle command. And, you can drop a point and make a circle like you would in a CAD system. But what I'm going to do with this fit polyline on, and you see these points, this is a segment. You just pick it, and it is going to fit a perfect circle through that scan data, okay? Pretty straightforward. You can take a look at it, say, yeah, that looks pretty good. Now, let's do the same thing again and pick that inner circle. And you'll notice this mesh sketch has some holes in it, like here and over there. That's just where there wasn't any scan data. And that's fine. It doesn't have to be perfect. It doesn't have to be watertight, okay? But going back to the second circle, you'll notice it's not concentric. It's very obvious. The center points aren't the same. They're not concentric. And usually, again, good design practices, these would be concentric. So, there's a few ways I can do this. I could just grab it and move it. For example, I could, draw the circle again and, click right on there and draw it. Or I could do it like that, like I did before, and then I could add this constraint. So I'd pick the outer circle, hold down my shift, double click, and then say, make those concentric. So they all do the same thing. And then I can also add dimensions. So let's pick the outer circle, and we can see it's 0.996. Well, would logic tell me that should be 1? Okay, well, maybe that's too big. Maybe it is 0.95. You can do whatever you want here, right? You can override the scan data and make it, of a specific size. Totally up to you. Okay. And at any time, of course, you can change this to, let's go ahead and just make it 1, because again, that would make sense. But now you see, and we can move it and say, okay, well, let's fit it here. I mean, we have a lot of discretion to how we want to do this. Okay. Because again, when we're scanning a manufactured part, it's not perfect. They never are. And if it's an old part that's worn out, this is very common where you have to make some decisions on what you want to do. Okay, so we've got our circles here. Now, let's go ahead and draw some lines. So I'm going to start here, and I want to turn off that fit polyline because I'm going to pick, and then I'm going to bring this over here, and you can see when it highlights tangent. Okay, I want to do that. And then for this bottom line, again, I could pick polyline, but you'll notice when I do that and hit OK, I don't get the vertical symbol, the construction, the constraint. Of course, I can right click it and say make it vertical, or I could draw a line, turn off fit polyline, drop my first point, and then make it, again, just keep moving it till I get that constraint. So all the same way to do the same thing, or different ways to do the same thing. Okay, now let's go ahead and add our radius in. We're going to pick this, and we're just going to move this until we get it right on there. You can add a value or specify a value or add a dimension. I'm just going to, this is just a nice curve, and this will all be tangent. Okay, so this dimension I don't think is critical, so I'm not going to worry about it. Now let's go to the trim command. I'm going to go power trim, and I'm going to pick this piece and get rid of it. Okay, so there's our first quadrant. Okay, everything's tangent, everything's vertical, horizontal. I've dimensioned this. I've made sure they're concentric. So again, all good practices, because you don't want to just trace over the scan data. If you're going to try to make things symmetrical and make them right and things line up, you're going to have a lot of problems if you just follow the scan data. Okay, so we have all that. Now I want to mirror that over. I'm going to pick this symmetry line, and then I'm going to mirror over this geometry right there. Okay, and then I'm going to repeat that command, pick this symmetry line, pick this geometry, and mirror it over. And you can obviously see there are, we deviate from the scan data. Now, the other neat thing we can do is under this Accuracy Analyzer tab, I can pick this deviation, and I can set a value, and I'm going to keep 4 thousandths as my tolerance, and then I'm going to multiply so I can see multiply the vectors so I can see the deviation. Okay. Now, ignore the big red. That's where we had no scan data at all. So, of course, it's going to be off. But what I'm really looking at is this. Okay. So you can see these little whiskers are color coded. So green is good, but then approaching red is out in the positive direction. And then approaching blue is in the negative direction. And anywhere I can highlight along here and see what that deviation amount is. And if you zoom in on the line, you can see that pink line and these little whiskers definitely correlate with each other, right? Because it's undersized here, and you can see by how much. Okay, but again, this is all pretty good. And again, if I want to follow certain dimensions and certain constraints, you're going to have to make a choice of how accurate you want to be to the scan data versus good modeling practices. So I'm going to say, hey, that looks great. I'm going to take it, and we're going to exit out of the mesh sketch command. Okay, so let's just hide our planes for a minute. Okay, so there we go. Here is our first sketch. Now let's turn back on our scan data, and now we're going to want to turn it into either a surface or a solid. So we go to our model tab. We're going to want to extrude in this case. These are all of our solid modeling options, and then here's all of our surfacing. So we're going to do an extrusion. We are going to pick that sketch, and then we need to give it, a distance. Okay, so if I pull this up, it'll kind of snap right to that top of that scan data. But you can see it's 0.52, and again, my gut tells me this was supposed to be 0.5. Okay, so we're going to key in 0.5, and we're going to go ahead and take that and hit OK. So now we have our first solid body. So let's hide the mesh for a minute. That is now a solid body. This is real geometry in the sense that I could export this right now, and somebody could CNC machine this or water cut it, or use it for other applications. Take it into a CAD system and do additional stuff to it. Okay, you've got planes, you've got cylinders, you've got circles. All of that is now an option, okay? Now, the other thing I can do is I can do a deviation on the body, and, we can look at this. So obviously the bottom should be pretty good because it's pretty flat, and that's where we started. But you'll notice the top, now you got to ignore this area because we haven't done anything yet. But here we can see we're undersized, right? The blue, and we know that because the scan data was 0.52, and we decided to go 0.5. We can take a look at our holes, etc. So it's just a quick color map. You can kind of see. This is really good when you get into kind of more advanced surfacing, okay? But let's turn that off for now, and let's go back to our mesh. So the next thing we got to do is look at, okay, what's our next feature that we want to model? Now, obviously, it's this part sticking up, and then the question becomes, well, which, we've kind of got a profile going this way, and we've got a profile going that way, and which way do you want to, start? You could argue all day long, and you ask two designers, you're going to get two answers, and it probably doesn't matter. I'm going to go ahead and model it this way, and then cut it off this way, okay? So this will make sense in a minute. Now, so we need a plane. I want to start on this backside. Let's turn our planes on. So right now, our right plane is here, but obviously we want a plane back here. So there's a few ways we can do this, okay? But what I'm going to do is I'm going to go click on our polygon tab. So I have my polygon selection tools. I'm going to use that where I can expand out, okay? And you don't want to go too far. You don't want to start going down the radius and everywhere. So you got to be careful. So click slide out till you kind of get what looks like a plane. And now I'm going to, there's a few ways we can do this. I could just go ahead and create another region. I'll just do that while I'm here and just put insert, and then I have it. And now go to the plane command. And what I'm going to do is use the extract command, and I'm going to pick that plane. Okay. Now, here's the thing. If I create a plane right now, let's go ahead and do that. And I build a plane. Oh, let's do that again. What a day. Oh, sorry. I got that turned on. So let me do that again. Okay. So if I build that plane, I click extract and I build that plane. Okay. You can see it fits a plane. Okay. And this is what I was getting at. We just had it set already. So let's turn off the other two planes for a minute. But how do I know this plane right there is parallel to this plane here? Okay. I mean, if this is slightly skewed and I use this as my plane for my next sketch, and then I start extruding and it's off a little bit, it's going to present problems down the road. Okay. So what I want to do is when I do that extract, okay, I'm going to pick again, and this was turned on, but we had a different plane pick. And then what I'm going to do is I'm going to say constrain the axis, and then for direction, I'm going to pick this right plane there. And now when it creates the plane, close it, okay, it looks almost the same, but let's hide the solid in the mesh. But if we zoom in, you can see they're different, right? Because plane 1 was right on the scan data. Plane 2 is best fit through that scan data, but we forced it to be parallel to the right plane. So we do not want to use plane 1. I'm just going to hide it. We definitely want to use plane 2. So these are just good modeling practices you got to get used to. You can't just assume, oh, well, this is, perpendicular to, our solid body down here. It wasn't, okay? And every a little bit, as you extrude or do things, you get farther away, get worse and worse and worse, okay? All right, so plane 2 is now good. We can hide the right plane for now. So let's build our next mesh sketch. So we go to sketch, mesh, we're going to pick that plane, and then same thing again. We're going to want to sample in, get off of that edge, come in a little ways, and then hit OK. But again, that mesh sketch will be right at that plane. Let's hide the solid and the mesh, and let's start building some geometry. Now, what's nice is you can rotate your view, because when it creates that true view on that mesh sketch, it's not always to maybe the view you'd like to see. And if you get into a view you like, you can just save it and then always recall it. Okay. Okay. So we want to start building some geometry, and we're going to want to make sure, again, we're maybe centered, so that we can make everything symmetrical. So there's a few ways we could do it. I'm probably going to draw a line from this point here. Make sure it is horizontal. And let's zoom in, and you can see as I move across, it's not perfect, but we're going to make it perfect. Okay, as far as being horizontal. And then I'm going to draw a line. And again, I'm going to snap to that center and just bring that down there. And then make that construction line. And then I don't need this anymore. So it's just, because these two lines are in angles, what's the best way to find the center? And make sure that's, oops, wrong command. And I got to make sure that is correct. There we go. Okay, so let's draw that. Okay, so that should be, at least from this point to this point, the center and being vertical, okay? So now let's start drawing some geometry. So just like before, I'll just click, draw that line, click, draw that line. And now what I want to do down here is I want to bring the solid body back, because what I want to make sure is when this line comes down, it's exactly at this intersection point. This will make sense in a minute. So what I'm going to do is what's called convert entity, and I'm going to pick this so that I make sure that I am getting, even though I'm over here, I want to make sure I'm getting, so when I hit OK, you're going to see what I get. Because I got to make sure, you can see how they're off, right? I want to make sure I'm drawing right to that point, not to this reference sketch. Otherwise, this stuff won't line up. Okay, so go back, double click my viewport. Okay, now I can hide that solid body for a minute. And this time when I draw this line, I want to make sure I'm snapping to that end point. And I'm not going to try to snap into that corner. I'm going to just come up short. It's hard to draw into a corner when you have a little radius, so it's better to use your trim command, and that'll find the corner for you. Okay. And now we can go ahead and start mirroring some things over. So we will go to mirror. There's our symmetry line. And we'll mirror over this, and this. We won't need that one actually, but that's okay. I can just delete it. Okay. So now let's go ahead and draw this line. Okay. And let's come up and draw our, now for the slot here, one of the commands we don't have that you do have in Design X is a slot command, and it's pretty nice. But we can get around that by using this rectangle command. So we'll just snap this here, kind of zoom in, get everything to fit real nice. Okay. And then use the 3 tangent arc command. So we pick, and then we pick here and pick there, and that'll give us a nice tangent arc. And of course you could make half of this and mirror it over. For time purposes, I'll just take what we have here, and then I'll use the power trim command to trim that up. And then let's draw our line, and I will grab here and then make sure I'm horizontal over there. Trim out that corner here and here, and then trim this to this and this to this. Oops, I deleted that line. Let's do that again. Actually, let's go back and undo and go and use power trim and get rid of the middle here. Just get all rid of these. Okay, so we have that all trimmed out. Now let's put in our radius. Now I don't put in small radiuses. I will do those in the solid model, but a lot of times the larger radiuses, it just kind of depends. I'll put that one in. We need to trim this out here. Okay, I won't bother with that fillet right now. And then finally, let's do our circle. And Let's see what happens when we fit a circle through there. Okay, so if we zoom in, once again, you can see things are not perfect. So what do? Well, I'm going to grab this and I'm going to move it over so it is right on that center. And again, everything can be dimensioned, okay? So if we want to throw dimensions on this stuff, we can. Normally we would. What should 0.4541 be? Maybe we just want to make it 0.45, whatever you want to do, okay? Or maybe you want to make it a completely different size, totally up to you. Okay, so now we have that next mesh sketch. Let's bring back our solid body and our mesh. Okay, and now we're ready to extrude, okay? So back to model, extrude. We're going to pick it. Oops, got to pick the whole sketch. Okay, so you can see here it's giving me an error. Why? Well, let's go back to our sketch. So in our history tree over here, double click. Let's go to our view. And let's turn on disjoint ends. Okay, and sure enough, okay, what do we have? Anywhere you have a disjoint end, you get these little green points here. And that's telling me it's not closed up. Well, if it's not closed up, you can't extrude it. Okay, so the only thing that it was able to extrude was that. Now you can go in and move the little points and make it all line up, or you can do this coincident constraint, hit OK, and that usually will find all of them. And let's see if that worked, even though that one was still on. Okay, and let's go back, turn on our mesh. And let's go ahead and extrude. Okay, so now you can see we have the whole thing. And the reason there was that one there is I think just where that construction line intersected it. Okay, so if you ever can't get your sketch to extrude as a solid, more than likely that's the problem. Okay, so you can go in again, manually do it, or use that command. Now I'm going to extrude this, and you can see, well, it's on an angle here. Okay, now one of the commands is you can extrude up to a region or a face, and theoretically we could go up and extrude right up to the angle. Problem is it's really two faces, right? You've got this angle here, but then you also have this one here. So we're going to have to do that in a separate operation. So we're just going to pull it out, somewhere beyond this face. We're not going to merge them at this point. Let's leave them as two separate bodies. So when I hit OK and I look in my tree over here, I've got two bodies, okay? So we've got the bottom and then this one. So now we're going to have to figure out how are we going to, trim this off, okay? And if it was just a single face, it's easy to do. Like I said, you can use a plane or even a region group, okay? But it's not. It's a combination of these two. So we're going to have to figure out a way to do that, okay? And what we're going to want to do now, again, I can make a plane and then a plane, but to me, the easiest way to do this is go to our top view, and I don't care where this section is. We'll leave it where it is. And I'm going to go to our sketch. I'm going to go to mesh sketch. I'm going to pick this plane. And of course, I don't want it there. I want to sample it way over here. Okay, somewhere in here. And what I'm trying to get at is somewhere where I can get all this data. Now, we also have this thing called, not only can I move where I'm sampling it, but then I can do a silhouette. Let me put this in the side view. And I can actually say, hey, look at this whole area and find the highest point, okay? So it's a silhouette of that area. Does that make sense? So that'll give me more data that I can use to create this, okay? And of course, it's kind of upside down. Flip it around, and this is just personal preference. I like to have things, in a certain view, so I'll save this view. Okay. And let's hide our mesh for a minute. Okay. So now what I'm going to do is I'm going to fit a line right there. And then I'm going to want a vertical line through here. And I'm just going to pick there and there. Okay. We want that vertical so it's parallel to the other one. I'm going to trim these two up. Okay. And I'm going to draw a line down here. And I'm going to trim this to that. Trim, pick here, and here. And the reason I do it this way is, as opposed to grabbing the point and pulling it, is when you do that, sometimes you can actually, move it. I want to keep it right on there. So that's the way I like to do it. Okay. Again, personal preference. So what I have now is a line that represents those two planes. Okay. And let's I'll leave the solids off for a minute and let's exit out. Okay. And yes, we had the disjoint ends turned on, but I don't care because I'm going to be doing a surface and it's not a requirement. So back to model. And instead of doing extrude here, I'm going to do an extrude here as a surface. Okay. So that doesn't have to be closed up. And this is just a surface skin. Okay. And I just got to make sure I go far enough. Let's go about right there. Okay. Surfaces are yellow, solids are gray by default. Okay. So, and the reason I didn't join them together, let's hide the mesh, is because if I were to cut this surface from this solid and it was hooked to this, we would cut off part of our part. So let's hide that and you'll see. So there's what I want to cut. So we use this command called cut. We pick the tool, which is the surface. We pick the target, which is the solid body. We hit next. We pick the side we want to keep. And now if we hide the surface, turn back on the other solid, turn back on the mesh, you can see what we have. Okay. So that gives us a nice clean cut. Let's look at our deviation analysis. Okay, everything looks pretty good. Obviously, we haven't cut this out yet, nor these here, but the rest of it looks, really nice. And you can hover over and look. So that looks good. Okay, so now if we want to put these two solid bodies together, now I can do a boolean, and you can, you can do this at any time. And I'm going to do a merge. I'm going to pick these two bodies. Okay. And since it's history tree modeling, if you ever find later, oh, I don't need them or I need them separated, you can just go back and either delete that operation or suppress it. So again, that's the beauty of solid modeling. Okay, so let's look at this again. Let's go ahead and do this cutout. Now, if we hide our solid body, now you're going to notice here we got a big radius here and then some radiuses going down the side. But I need to cut out the basic shape first. So here's what we're going to do. Okay, we're going to go back, turn on our solid for a second, turn it back off, and I need a plane, again, on this face. Now, I could offset plane 2 some amount, but maybe I don't know what it is, but we could certainly do it, or we can do what we did before, which is sample this data here, okay? And again, I'll just create a region just so we have it. You can essentially just tell it to create a plane. Go back. We're going to plane. We're going to do extract. We're going to pick this guy here. Okay. And then our axis constraint will be plane 2, which is also parallel to the right plane. And we hit OK. And so again, we've got a plane that is parallel to plane 2, but on this face here. Okay. Turn off our region groups. Okay, so same thing, sketch, mesh sketch, pick that plane. And again, I'm gonna need to pull it out. And I wanna get it out so I'm down here on the flat. See if I pull out the silhouette, that'll help me get up a little bit, okay? And let's hide our mesh. And again, we could go through the process of making sure everything is, symmetrical. For time purposes, I'm just going to go ahead and pick. I will make sure this one at the bottom is vertical, or sorry, horizontal. Yeah. And then I'm just going to draw a line. Oop. Short. Let's do that again. Let's draw that up there. And then we're going to trim everything out. And again, I'm purposely avoiding all the radiuses right now. Okay. Okay, so there's our sketch. Let's hide it. And again, good practice would be make sure everything is symmetrical. Okay, so there it is. Let's bring on our solid body. Let's hide our planes. Now we're going to do a extrusion. We're going to pick this. And this time we'll go ahead and use the cut modifier and let it go ahead and cut that away. And you can see what we get. Okay. So again, we've got a nice cut. Now, let's do this real quick. Let's double click that again. And if we click opposite direction and we go up to a surface and pick this guy, make sure we're right on that face. Yep, there we go. Okay. All right. So that all looks good. Okay. What do we have left? Well, I think we've got primarily some fillets, but we've also got a couple relief cuts down here, probably for washers or bolts. Okay. So let's hide the mesh for a minute. We're going to go back to sketch. Okay. Now, one of the differences with Design X is there's a 2D sketch and a mesh sketch. You only have mesh sketch in Design X Essentials, but it's really not a big deal. As long as you have a mesh in here, you can use it and kind of act like a 2D sketch. Okay. So for example, I click mesh sketch and I'm going to just pick this plane right on the solid body as the plane that, I want to reference. Let's hide and then I'm going to pull it up. And I want to get just a little bit of this radius here. And then enough of this one and get off this radius down here. Just so I can get those profiles. So I'll hit OK. Now we have to think about this again, just like the other stuff we did, which was, okay, should these be concentric to these holes? So for example, if I fit a circle here, I can obviously see it's not, okay? But maybe I want it to be. So again, few ways to do this. Easiest way I think is just convert entities. And I pick those two and it's going to extract some info. Okay. And give us that center point. And then now I can just pick and I'll just pick the center. And these are for clearance. So, I just got to get it close. But again, they're going to be nice and concentric. Okay. And then I can either just delete these or turn them into construction geometry. I like to leave them in my sketch. So if I ever go back, I can see what I did. Like, oh, okay, I used those. Okay. There we go. So we have those. I'll bring the mesh on so you can see what we're doing here. And again, we're going to do an extrude. We're going to pick this. I don't need to go that high. And we'll do a cut. And we'll cut that away. Okay. And again, we know it doesn't match, but I want everything to look nice and line up. Okay. So we've got that. Now we just need our radiuses. So we've got a few radiuses. We put that one in, but we didn't put these down here. Now what's really neat is I can go under the fillet command. I can pick this corner right there. And I have no idea what that radius should be. I click this here. It's going to go look at the scan data. It's going to figure out what that radius should be based on the scan data. 0.4895. I'm betting that's 0.5, or I'm going to make it 0.5 because that would obviously be easy to machine. We'll repeat that command. We'll pick this one. I'll trigger it again. But again, 0.52. I'm making it 0.5. Let's go ahead and take that. And I believe we have one here on the back. Yep. And, you can just visually look at it too and say, yeah, that looks about 0.5. Let's do it. Okay. And now we've got this big one. Let's do that one first up in the corner. Again, let's query it and see what it tells us. 0.499. It's about as close as 0.5 as you can get. And then if you remember, we've got these smaller ones coming down the side here. Let's pick this and this. Oop. Select. And you can pick, the intersection. You can pick faces. It all just kind of depends. Okay, and then for this one, we'll make it 0.15. Okay, and then hit OK. Okay, there we go. Let's bring our mesh back on. Okay, so you can see what we've done. I believe we've got everything here. Let's do our accuracy analyzer. I'm not going to bother putting the text name in there. But there we go. Okay, so what have we done here? We've built a solid model, okay, from scan data, but we followed good design practices. We made things symmetrical. We made them parallel. We made them perpendicular. We added dimensions so that you get a good part ready for manufacturing. Everything is flat. Everything is true. Everything is ready to go. And again, why did we have to do that? Why couldn't we just take this scan data and send it to a machine shop to have this made? Because they can't work with this data, okay? If you look at it, again, it's just a bunch of triangles, okay? There's no intelligence to this. They can't machine it. They can't really do anything with it, okay? if you go to export this, your only option, if you pick this mesh, is an STL file, okay? And again, that's just triangles. Where the CAD file, now we've made everything the way it's supposed to be. And when we go to export this, we have options such as IGES, STEP, Parasolid. Those are the three most common neutral CAD file formats. You can bring this into a machining system or a laser cutter or a water jet, or, going to do some mold design, whatever it may be. Every CAD system can load this file and it's going to look just like this, okay? They can build drawings from it. They can bring it in with an assembly of parts and add all the assembly constraints. They can do whatever they want with it, okay? Now, in Design X, there's actually what's called live transfer, and that will actually open up the host CAD system, SolidWorks, Siemens NX, Inventor, and a few others, and it will actually rebuild this tree. I don't want to get too technical here, but it'll actually rebuild the whole history tree. When we export this in Design X Essentials, it's going to be a neutral file. There'll be no tree here. But again, most CAD systems can work with this without a problem, okay? So that's really just a brief overview of what you can do in Design X Essentials, okay? And of course, there's a lot more stuff in here, but I want to just take you through and show the whole process of reverse engineering on a pretty straightforward part, okay? But and introduce Design X Essentials at the same time and show you this process. So that's what we're trying to do here, is take scan data and turn it into CAD data. And obviously what takes time is just how many features, how complicated the part. This part's pretty straightforward. Other parts could take, hours to days, depending on their complexity. So that's a little bit here on Design X Essentials. So this wraps up the video on Design X Essentials. And as we mentioned earlier, if you just want to see a head-to-head between the differences between Design X and Design X Essentials, check out the video in the link below, and you can watch that. Now, again, if you want to learn more about this, get a demo, like a web-based demo or a benchmark, or you want to do your own trial, then reach out to us. Our phone number is 877-845-2700, or you can email us at info@ems3d.com. Also, in the description below is a link to a quick contact form. If you want to do it that way, just put your info in there and we'll reach out to you and get in touch and find out, what you're trying to do and, what's the right tools for you, or maybe you want to look at a 3D scanner. We can really help you with anything related to scanning, reverse engineering, and inspection.